if I toss a coin, now the possible sample space would be heads or tails. So it could either appear a head or it could appear a tail. So head and tail is the sample space. Anything beyond heads and tails is not possible. So S is H comma T, where H is head and T is tail. Now when two coins are tossed simultaneously, then what are the outcomes? Either it could appear heads heads, or it could be head tail, or it could be tail head, or it could be tail tail. So these are the four possible outcomes, and the set of all these four outcomes is known as a sample space. Now each of these is a sample point. That is, this is an element, this is an element, this is an element, and this is an element of the sample space S. So the set of all possible outcomes of a random experiment is known as the sample space and is denoted by S, and every possible outcome of such a set is known as a sample point. The third is trial. The performance of an experiment is called as a trial and the outcomes are called as the cases. The number of times the experiment is repeated is called as the number of trials. So if I toss a coin, now this is the performance of an experiment, that is tossing of a coin, and so it is called as a trial. And if it is a head or it is a tail, this is called as the case. The case one could be it could appear a head or it could appear a tail. So I'm sure the distinction between a trial and a case is clear. Now I may toss a coin twice, thrice, 4 times, 10 times, 20 times and so on. And so the number of times the experiment is repeated is called as the number of trials. The fourth is event. Now what is an event? The possible outcomes of a random experiment are termed as events, and it is a subset of a sample space. For example, when a coin is tossed, the outcome of getting a head or tail is an event. Event is nothing but the possible outcomes of any random experiment. So if we toss a coin, it could appear a head or it could appear a tail. So head or tail is an event. Event 1 could be appearance of head and event 2 could be appearance of tail. Now the bifurcations of events could be simple events, compound events, equally likely events, independent events, mutually exclusive events, exhaustive events. One by one we are going to see different kinds of events. The first is a simple event. Now in the case of simple events, we consider the probability of happening or not happening of single events. So we consider a single event and we try to consider the probability of happening of that event or not happening of that event. So for example, if I say that we are interested in finding out the probability of drawing an ace from a pack of cards. So drawing of an ace from a pack of cards is a simple event. The second is compound event. Now in the case of compound event, we consider the joint occurrence of 2 or more events. Earlier in the simple event, we considered only a single event and we were interested in calculating the probability of occurrence of that single event. But in compound events, we consider the joint occurrence of 2 or more events. For example, the occurrence of an odd number when a dice is thrown. Now if I say that I am interested in knowing the occurrence of an odd number when a dice is thrown, possible outcomes are 1, 2, 3, 4, 5, 6. And out of these possible outcomes, 1, 3 and 5 are the instances when an odd number is occurring. So this set 1, 3, 5 is a compound event. The third type of event is equally likely events. The events are said to be equally likely if there is no reason to expect any one event in preference to other. Thus equally likely events mean outcome is likely to occur as any other outcome. So we say that there are 2 events and there is no such reason to expect the occurrence of one event in preference to the other event, then such a case is known as equally likely event. For example, if I throw an unbiased dice, then in throwing such a die, all the 6 faces are equally likely to occur. That is, it may appear a 1, a 2, a 3, a 4, a 5 or a 6. That is to say, there is no such reason to expect 1 or 2 or 3 in preference to the other numbers. Thus all these 6 faces are equally likely to occur. So this is an equally likely event. Another example could be if I toss a coin, then it may appear a head or it may appear a tail. Again, these are equally likely events. The next is independent events. The 2 events are said to be independent if the occurrence of one does not depend on the occurrence of the other. So as the word suggests, independent events are such events in which the occurrence of one does not depend on the occurrence of the other. Now we are going to study independent events in detail in later part. What are mutually exclusive events? In an experiment, if the occurrence of an event precludes or rules out the happening of all other events in the same experiment, then such events are known as mutually exclusive events. That is to say, if we are performing an experiment, then if one particular event occurs, then all other events are not going to occur. So the occurrence of any one event rules out the happening of all other events in the same experiment. If we say that E1, E2, E3 and so on up to En are mutually exclusive events, then E1 intersection E2 intersection E3 and so on up to the intersection of En would be equal to 5. That is a null set. These are mutually exclusive events, then the intersection of these events is equal to 0 or a null set. The next is exhaustive events. What are exhaustive events? It is a total number of all possible outcomes of any trial. So the total number of all the possible outcomes of any trial or any such experiment is known as exhaustive events. For example, when a coin is tossed, either head or tail may turn up, and therefore there are two exhaustive cases. If two coins are tossed simultaneously, then the possible outcomes are head tail, tail head, tail tail, and so this would be equal to 2 square. So there are 4 possible outcomes. If 3 coins are tossed simultaneously, then the possible outcomes are head head head, head head tail, head tail head, tail head head, tail tail head, head tail tail, tail head tail, and tail tail tail, and this would be equal to 2q. That is, there are 8 possible outcomes for this experiment. Similarly, when 3 dice are thrown simultaneously, then the possible outcomes are 6q. And so exhaustive events are nothing but they are the total number of all possible outcomes of any trial. Now let us try to understand the algebra of events. Now if we say that A and B are 2 events, and these 2 events are associated with the sample space S, then we can have this sample space, that is S. We can have an event A and we can have another event B. Now A union B is the event that either A or B occur. So this is A union B. Now A union B means that either A or B or both of them occur. The second is A intersection B is the event that A and B both occur simultaneously. So this event, that is A intersection B, represents the occurrence of A and B simultaneously. Now A complement is the event that A does not occur. So all this space which does not include the event A is known as A complement. So we can say that A plus A complement would be equal to the sample space S. And the fourth is A complement intersection B complement mean none of the events A and B occur. Now A union B means that either A or B or both of them occur. A intersection B means the event that A and B both occur simultaneously. A complement is the event that A does not occur, and A complement intersection B complement represents that none of the events A and B occur. Now let us consider an example. In a single throw of die, let A be the event of getting an odd number and B is the event of getting a number greater than 2. Then A would be the set 1, 3, 5 as these are odd numbers, and B would be 3, 4, 5, 6 because these are the numbers greater than 2. Now we have to find A union B. Therefore A union B would be equal to 1, 3, 4, 5 and 6. That is the event of getting an odd number or a number greater than 2. So we see here that the event of getting an odd number or a number greater than 2 is A union B, and which is equal to the set 1, 3, 4, 5, 6 in this case. The second is A intersection B. This would be equal to 3, 5 as these are the common points of these two sets. So A intersection B would be 3, 5, and so we can say that this is the event of getting an odd number greater than 2. So the event of getting an odd number which is greater than 2 would be 3, 5. Now we see that A is the set 1, 3, 5. Therefore A complement would be 2, 4, 6. That is, these are the elements of S which are not in A, or the event of not getting an odd number. If we are interested in finding the event of not getting an odd number, then that would be equal to A complement, and which is equal to 2, 4, 6. And so these are the elements of S which are not in the set A. The fourth is A complement intersection B complement. Now this would be equal to 2. That is the event of neither getting an odd number nor a number greater than 2. So thus A complement intersection B complement is equal to the single element 2. So this was an example to understand the algebra of events. Now what are mutually exclusive and exhaustive events? Now we have earlier seen that a mutually exclusive event is such that if one event is happening, it rules out the possibility of happening of other events. If we say that E1, E2 up to En are mutually exclusive and exhaustive events, then the first condition is E1 union E2 union E3 and so on up to En would be equal to S. Your S is the sample space, and Ei intersection Ej is equal to phi. So